I believe this integral should have more than one method to do, but it's not easy. Now, here is my method I would like to share with you. I call this integral I, and I create another integral j, which is equal to sine x cosine x over sine cube x plus cosine cube x dx. Obviously, that I want to create two simultaneous equations, I and j, so we can find the I. Now, before I continue, I want to recall some basic formula, which is sine cube of x plus cosine cube x should be equal to sine x plus cosine x multiply sine square x minus sine cosine plus cosine square. Well, that is a basic algebra, right? Now, there's another one we can recall. That is a 1 minus sine x cosine the square. That's easy because this square plus this square is equal to 1. The midterms are 2 sine cosine. So 1 cancel out. So this is equal to 2 sine x cosine x. Okay, these two formulas are useful in our integrations. Now then, I create I minus j. I minus j will be equal to integral. Well, it's a long fraction. So denominator will be sine x plus cosine x multiplied by sine square x minus sine cosine plus cosine square x. The numerator will be this minus that, right? 1 is what? 1 is a sine square cosine square. That's 1. This is this one. Minus sine x cosine x, right? That is this one. And then dx. Then obviously this one cancels with that one, right? Left over this dx sine x plus cosine x. Yeah, great. Now then, well, let me try use this formula. This is cosine x minus quarter pi based on the basic trigonometry. This is cosine A minus B is cosine A cosine B plus sine A sine B, right? So this one is equal to cosine x times this one. This is a 1 over root 2, right? Cosine quarter pi. Plus, this is minus, this is plus. Sine x times sine quarter pi, which is 1 over root 2. So therefore, this common factor out, sine x plus cosine x. Therefore, sine x plus cosine x is a root 2 times this. So this becomes root 2 times this. The cosine. x minus quarter pi dx. Yeah, good. Then then we finished, because this is a more or less finished. This is secant, right? Secant x minus quarter pi. Dx is the same thing as x minus quarter pi. There's no difference. So this one equal to 1 over root 2 natural log secant integral is a secant x minus quarter pi plus tangent x minus quarter pi, right? Plus C1, yeah. Yeah. Okay. Okay, good. Now then, well, I need another equation to solve for I and j, right? The other equation is this: I plus 2j. This will be integral, and the denominator is this, right? Is sine x plus cosine x times sine x squared minus sine x cosine x plus cosine square x. And the numerator is 1 plus this plus 2 of that. This 1 is a sine square plus cosine square plus 2 sine cosine. It is just the perfect square, right? Sine x plus cosine x squared and dx. 1 plus this is this. Now and then we can cancel one of them, right? And becomes sine x cosine x. And this is gone. This is sine square minus well, this is 1, right? Simply 1 minus sine x cosine x. Yeah. Wow, that's better. Then this one equal to, now we're using this formula. Not formula, use this equation, huh? I'll leave it for you to develop. This is equal to 1/2 1 plus sine x minus cosine x squared. From here to here, I'm using this formula. And you can detail, you can, I'll leave it for you to derive that one, okay? And this one is equal to the derivative sine x minus cosine x. This derivative is cosine. This derivative is a sine. So therefore, this becomes 2 arctangent sine x minus cosine x plus C2. Yeah. Then we can find I, right? We're looking for I. I is equal to 2I minus j plus I plus 2j. This is 3I. J cancel out times 1 over 3. Yeah. So we have ij. We have I plus 2j. So it becomes 1/3 root 2 natural log absolute value secant x minus quarter plus tangent x plus quarter pi and plus 2 over 3 arctangent sine x minus cosine x plus big C. All right, so this integral is it's not that easy, but this method is really good. The method is really good. Now I have another video doing this integral with the same method, similar method using ij, okay? And the linkage is below. You can go see it. And I hope you like it. Thank you very much.